In this video, we're going to deduce the structure of an unknown molecule C7H8O. So if we go into the NMR like we do with all of them, let's look at what we have and, importantly, what we don't have. So here we have between 6 and 8, we have benzene protons. Notice there is a 4 there, which means it's di-substitute. So there's 2 groups on that benzene. We then go for here between 4 and 5. You can see this nice peak that separates out the bond. It's quite wide at the bottom if you look at it here compared to the other one. So because it's slightly wider and it's got 1 by it and it's very small, that is indicative of an alcohol group. So I think we've got an alcohol group here. And then we go to this last one here with 3 by it. Now that 3 says it's a CH3, but it says it's next to a carbon with no hydrogens on it. So that's why it's a singlet, but we'll go through that later. And we can't see any other functional groups now, nothing like aldehyde, nothing like that, no carboxylic acids or anything like that. You can't see anything else. So pretty sure this is an alcohol and that oxygen is used up. Here's the table. Here's your chemical shifts. Here's your peak splitting and your peak areas. Okay, as said, we think that you will have a CH3, an OH and a benzene. But first of all, let's do our environments, 3 hydrogen environments, and do our n+1 rule. So the singlet means that the N is equals to 0, and therefore there are 0 hydrogens on the adjacent carbon. Or for example, if it's the OH, you can't peak split through an oxygen. It blocks that peak splitting. So any OH is going to be a singlet, regardless whether there's a carbon next to it with hydrogens on. So let's put them in, CH3 and C6H4. And then let's check that we have all of the right atoms. So, looks like there's no atoms left. So our molecule is only made of these 3 parts. Let's put that over to the side and start drawing out our molecule. And there's a couple of things I want to talk about when it comes to drawing out the molecule. If we have the molecule like this, we know we've just got 2 groups. There's 2 substitutions, two places on here where the groups can go. We've got a CH3 and we've got an H. So it makes sense that CH3 is here and the OH is here. Now, if this was a question in the exam, your OH could be here, here or here. Doesn't matter. Okay? They can't assess you on the exact places. There's also a really important point, and we do go over this in a D2O video. So if you want to talk about D2O in a bit more detail, you can do it in the, you can watch it in the D2O video. But this proton here, that will exchange, and it'll exchange with deuterium in D2O. Okay, so if I added D2O, okay, that would change that H for a D. Okay, so if that is the case, you would get a new substance that looks a bit like this. Okay, and it would just be OD there and then CH3. Now, when it comes to D2O, normally slightly acidic protons, labile protons, ones that leave easily, are exchanged with the deuterium. And the thing is that this deuterium here, okay, it is not seen in Proton NMR. Okay, so this one right here, you don't see it. So basically, as you go from here to here, your peak disappears. So you would no longer have, your peak disappears, and you would no longer have this alcohol. So this one here, that would go. Okay, this one here, that would disappear. And it would disappear in D2O. And I just wanted to highlight that, and I will highlight that as I go through the videos of different functional groups that might, and I will discuss when D2O would make this disappear, because they can put that in the exam, okay, and they can put it in question. But again, if you want to go through it in detail, then there is a D2O NMR video available. So in doing this NMR, we have used the relative peak area to deduce how many substitutions there were, and we saw this very characteristic peak. Now, I'm not going to go through the entire coupling on this, but if you look at this character, it's like two doublets. And that usually means that the groups on the benzene are either side of the benzene, so 1, 4. Okay, so, but again, you're not assessed on that, so do not worry if you put them in different positions. Anyway, so 4 is disubstituting, we used that, okay, and then we decided there was no atoms left, okay, and we decided that there was an alcohol, because that's a slightly broad peak, okay, and we used all of that, okay, to deduce this disubstituted benzene, including phenol and including that methyl group. And we also went over how D2O would make the phenol proton disappear.